What's up, math scholars? We are just about arriving at a 4-day weekend, so everybody's having a happy day today. Just remember, the best time to be a math scholar is all the time. Who's excited for a 4-day weekend? We are on our last 2 properties on the sheet. As Dylan says, everybody's saving paper. We did our whole notes for the whole week on one piece of paper.
I love it.
Oh, yeah, I ran out of extras too. A zero exponent property basically states that any number to the 0 power would be 1. Anything raised to the 0 power is 1. So let's try the 2 examples that you're seeing here. The a to the 0 would become a 1, and then we'd have the b to the 3rd. So that final answer would be b to the 3rd. No, because there's no other b. The a and the b aren't the same variable. And then on this one, everything gets raised to the 0 power. The 25 gets raised to the 0 power. The c cubed gets raised to the 0 power. And the d7 gets raised to the 0 power. What do you think it would be?
I was going to ask, how come it was the a to the 7th power, or a and then b3?
Because a to the 0 equals 1, so it's like this whole entire term just turns into the number 1. It's not a to the 1st, it's just the number 1.
Oh.
Does that make sense?
How can we get rid of the 1 and just write b to the 3rd?
Alright, so we were talking about the 0 here. 25 to the 0 is 1. If 3 and 0 multiply, it's 0, so it's 1. So basically this whole entire thing just kind of collapses down and gives me 1. Isn't that wild? So that's what the 0 exponent does.
That's not wild, it's crazy.
And then my final song of the properties chapter, it's the song I sing for negative exponents, and it goes like this. Flip and make it positive. Can you sing it with me? Flip and make it positive. You do never, ever, ever want negative exponents in your final answer. So what you do, you can kind of see it demonstrated here. They take this a to the negative n, they flip it to the denominator, and n magically becomes positive. That's why it's called flip and make it positive. Now this is even crazier. It's in the denominator, and it flips to the numerator and becomes a positive. Okay? So once you're done writing that down, we'll try these examples over here on the right. All right, so let's look at this example problem. Hopefully I have enough space. I write really big. The 4 and the 16 are normal numbers. We're just going to reduce the fraction 4/16. Do you know what that would be? Very good. 1/4. This a to the negative 3, guess what I'm going to do? Flip and make it positive. So he'll be living down with the a squared because he doesn't need the flip. You only flip the guys that are negatives. This b to the 6, he's okay, so he can stay put. But this b to the negative 2, what's he going to have to do? Flip and make it positive. Now I got to clean up this answer a little bit. My b's can add together, so it would be 1b to the 8th on the top, or just b to the 8th. This was a b to the 6th, and a b squared joined him, so I added them to make an 8. And then the bottom, this a to the 3rd and the a to the squared can add up, and then they would become an a to the 5th.
That's amazing.
That's my final. I tried to write really small, like space.
She graduated.
I graduated. All right, any questions on that one? There's a lot of letters in that one. Yeah? Okay, let's look at this next one. We kind of had a chat off the video about you only needing to flip the variables that have the negative exponents. So like this x to the 4th doesn't need to flip. He's already positive. The y to the 0 equals 1, so it's almost like he's gone. But this x to the negative 2, it has to flip to the numerator so that it can become a positive. And then we have our answer, x to the 6th. So we can add the 2 and the 4. All right, let's try a few of these together. They do involve negatives, so they're a little bit confusing. As soon as I see that negative exponent, I say to myself, flip and make it positive. So if this 3 right here is in a numerator position. To flip it, I need to put it in a denominator position. So I will put a 1 up top to kind of hold my empty numerator. This 2 will become a positive 2. And then you can leave it, or you can actually calculate out what 3 squared is. It's a 9. So the answer to that one's technically 1/9. What's going to happen in part B? Actually, I don't know what they want us to do in part B. But never mind part B and C. Well, I found one that has some variables. We could talk through what's going to happen here. This definitely is a display of several properties at play. Any ideas on how to start? Ken? Done. Now, a lot of people have been doing 2 times 3 and getting 6. That's not it. Do you know what to do? It's 2 to the 3rd power. So 2 times 2 times 2. That's 8, right? Then the x will be to the 3rd. What will happen with the negative 5 and the 3? These two multiply or add? You guys know? Multiply. When they're right beside each other, it's called power of a power. I mean, you have the property sheet in front of you. Power of a power, we multiply. So I figured out that 2 to the 3rd was 8. The x to the 3rd can stay where he's at. He's positive. But this y has a problem. We don't want any negative exponents in our final answer. So we're going to flip the y to the denominator and make the 15 a positive. Flip and make it positive. Okay, we found a good one to do next. I want a scholar that's got a plan. Who's got an idea? Okay, I do like the idea of drawing a line and creating a fraction. I don't think we're going to need a 1 on the top, though.
We'll need a 5 on the top.
Very good, Melanie. That 5 is going to stay put, so that 5 can stay in the numerator. Okay, what's going to happen with the m? It has a negative exponent.
Flip.
Flip and make it positive. What's going to happen with the n?
Same thing.
Flip and make it positive. There's our answer. We'll just keep chugging away because all these look a little different. They all give you different strategies. We're taking notes today, right? Ken and... All right, here's our next problem. You could flip immediately and make that 3 a positive, or you can distribute it through. What would you guys think to do? Distribute it through? Okay, so most people are thinking let's distribute it through first. It does not go to the 9, but it does go to the 3 and the d. Those are separate guys, the 3 and the d. The 3 gets an exponent of negative 3, and the d gets an exponent of negative 3. Does that make sense?
Yeah, flip it though.
It does not make sense. All right, so here's where we're at. I had a student going, we got to flip still. We got to flip still. We absolutely have to flip still. Is the 9 going to flip? No. He stays in the numerator. He does not have a negative exponent. Does this 3 that I'm pointing to flip?
Yes.
Yes. It flips and becomes a positive. And then does this d flip?
Yep.
Yes. It flips and becomes a positive. Now it's 3 to the positive 3. Now it's 27. It wouldn't have been 27 down here, okay? But it's 27 up here. What is 9 times 27?
36.
Bigger than that. 9 times 27. What is it? Thank you. I knew somebody would have a calculator handy. The class saw this and they went, whoa! It's so easy. It's just 1. If you have a whole group of things to the 0 power, it's just going to be 1. And I actually haven't even had you prove this. Can you guys prove it to me? Can you type in 50 to the 0 power on your calculator just to kind of prove it to me and prove it to yourself? All right, the students typed this in. They did report back that they got 1, so it just kind of proves to you that anything to the 0 power is 1. Yeah, let's do this one. We'll do this one next. All right, we're going to give this one a try because there's negatives all over the place. We're going to see what would happen. What do you scholars think we should start by doing? Okay, so we'll distribute this negative 3 to these 3 places. So it'll be 6 to the negative 3rd power. It will be x to the what power? This negative 2 and this negative 3 will multiply. Very good. Yep. And then y will be to the what power? They will multiply as well. These two will multiply. Good job. So here's where I'm at. I don't want any negative exponents in my final solution. Who needs to flip? Not everybody.
The negative ones.
The negative one. So the 6 will flip to become positive. The y will flip to become positive, but the x will stay where he's at. I'm going to leave it like that. If you actually want to figure out what 6 to the third is, you can. I think it's like 216 or something, but you're good leaving it like that too. 216. Okay.
What?
All right, I'm going to give them this to try it as a graduation problem. Let's see, just take it piece by piece, baby steps at a time, okay? I think you can do it. All right, let's talk through this one and see if anybody graduated. This -2 goes both to the 2 and to the x, giving me 2 to the -2 and x to the -2. The y's just hanging out. He's still y to the 5th. We chatted off camera or off recording about this -4 and if we'd want to flip him. We determined we are not going to flip him. He doesn't have a negative exponent. That's the requirement for flipping. So as you're stepping back and you're looking, you have 6 things right now. You have 3 on top and you have 3 on bottom. How many of the 6 need to flip? Very good. It's just these 2 on the upper left. I'll underline them for people in the video. It's these 2. Everybody else will stay where they are. So the 2 will flip to the bottom. The -4 is hanging out on the bottom. The x will flip to the bottom to join the x squared that's already on the bottom. The y squared is going to be still at the bottom, and the y fifth is still going to be at the top. There's a lot of stuff to combine here. Let me make my slide bigger. I didn't anticipate needing this much workspace. Whew. So on the top, I think we're just going to have y to the 5th in our final answer. What is 2 squared times -4? -16, right? Because 2 squared is 4. What's going to happen with the x squared and the x squared? Add together. Very good. And then the y squared just hanging out. Oh, wait, no. Gosh, I didn't even notice. We have a y to the 5th on the top and a y squared on the bottom. Y to the 3rd on the top because you do bigger minus smaller. There is so much going on in this. Did anybody graduate this or not? Wow, you guys should be very proud. Like those, if you got this, you are a true scholar today. Very good.
Graduated.
There is a 7.3 varsity learned for the weekend. Have a good weekend.